we still construct a confidence interval, which is, in this case, we construct a confidence interval for a population proportion. Okay, so again, we no longer construct a confidence interval for the mean. We construct a confidence interval for population proportion. So before we do that, before we do a confidence interval for proportion, let's take a look at the notation and the item that we need to use in order for us to find this confidence interval for this proportion. So looking at this item here, the first thing is the P will be your population, the P will be your population proportion, which is, that is what we want to guesstimate. We don't know the population proportion, so we have to use some sample to guesstimate that proportion. Okay, so that's what we try to do. Our goal is we guesstimate where the P will be between. The second thing is the X is the number of the individual that fit the specific criteria of specific category. So in this case, basically the X is the people that you use the item. So for instance, if I say 5 out of 11 people use an iPhone, right? Meaning again, 5 will be your X, which is the 5 people that using the iPhone, which is the category or the criteria that they ask you, right? And the 11 will be the total number, which is again the N, which is the number size, which is the N will be 11. So if I say 5 out of 11 people using iPhone, which is the 5 is your X, and the 11 is your N, which is the total. And now the P hat, ladies and gentlemen, the P hat, this is your point estimator for your population proportion. Remember, on 7.1 and 7.2, the X bar, the sample mean, is the point estimator for the population mean. In this case, the point estimator for the proportion is the sample mean, and the sample mean is P hat. And the P hat is basically you take X divided by N. So if I ask you what's the proportion that people use an iPhone based on the number I say, well, you say 5 divided by 11, so a little bit less than 50%, right? So looking at this thing here, a few terminology to go along the way, which is I mentioned to you guys the point estimator. And again, if you remember yesterday, what is a point estimator? Well, the point estimator is a point that we use to estimate, right? A point that we try to use to estimate the population item. So in this case, the point estimator for a population proportion is the P hat, which is to find P hat, you take X divided by N. And similarly, we have to find a standard error. And to go back to chapter 5, the binomial distribution, to go back to that, the standard error based on a proportion is basically P hat is equal to, the standard error of this is a square root of P hat multiplied to 1 minus P hat divided by N, which is, again, this item is basically the same as your P times 1 minus P divided by N, which is your standard deviation for the binomial distribution, okay? And the other thing that we need to find a confidence interval is we need a margin of error. And a margin of error is basically a critical value times the standard error, right? So a critical value, to find a proportion, we go back to the Z critical value. And the Z critical value is basically the value on the bottom of your table A3, right? So once you have that, you take the critical value times the standard error, that will give you a margin of error. And now how do you find a confidence interval? To find a confidence interval, we have a point estimator, a point estimate plus the margin error, and a point estimate minus the margin error, which is, again, that is what we have in the sense of your confidence interval. You have a smaller endpoint on the left and a bigger endpoint on the right. Okay, so looking at this thing here, there are a few things that we have. There are a few assumptions that we need to make in order for
that slide really quick so I can copy the bottom.
Again, there are some assumptions that we need to make before we can use in this item here, which most of the time, again, I post this on Canvas, so I try to post it earlier today. Yesterday I posted a little bit late, but again, I have, okay. See, the assumption is this, which is, first of all, the assumption is your item have to be random. Your item, whatever you try to do, whatever you try to collect have to be random. And the other thing is the population have to be at least 20 times at larger than the sample. Meaning if you have 10 individual, your population have to be 200. Okay, so again, that's the assumption is the population have to be 20 times bigger than the sample. So again, 10 times 20, that's why we have 200. And again, the item will have two categories, which is either you use an iPhone or you don't use an iPhone, right? And again, the sample must contain at least 10 items. So again, which is the N have to be 10 or more. Okay. So again, most of the criteria will meet. So you know, most of the question they ask you, they will met those assumptions. But let's take a look at this thing here. Let's take a look at example 1. And again, let me do this way first, and then we will do the other way so that you can see how the material is. Okay. So look at this thing here. In a survey of 517 music teachers, 403 of them say that the video game Guitar Hero and Rock Band have a positive effect on music education. Construct a 95% confidence interval for the proportion of a music teacher who believe that the game have a positive effect. So again, looking at this thing here, everybody see that again, very easy to spot 7.3, right? When you read a question and they ask you to construct the confidence interval for a proportion, you know that you're in 7.3. The other one is a little bit harder because they ask you to construct the confidence interval for the mean. Both of them say the same. Construct the confidence interval for the mean, which is in 7.1 and 7.2. In 7.3, if they say construct the confidence interval for the proportion, then you know you're in 7.3. You know that you have to use the Z critical value is the same as 7.1, the Z critical value, and then you have to find the p hat and all of the square root stuff item, right? So let's take a look at this thing here. So looking at this thing here, we know we're in 7.3. We know we're looking for a proportion. So looking at this thing here, what information do they give us? Which is how many people do we have in the survey? Do you agree that in this case, we have 517 as in our N, as in our total? And again, because it's in the survey, if you remember in chapter 1, if it's in the survey, we are dealing with statistic, which is we deal with a sample number, right? We're not dealing with a parameter, right? So again, looking at this thing here, 517 is your N. How many people agree that they have a positive effect, which is that your X, which is 403? And again, now looking at this thing here, we need to have, in order, again, looking at this thing here, we can find a p hat, which is the p hat is X divided by N, which is again 403 divided by 517. And again, this will be your point estimator. This is the point that you want to use to estimate the population proportion. Okay, so once we find a point estimator, this is what we need to do is we need to find a standard error and we need to find a critical value, and then we multiply them together to find a margin of error. But let's find a critical value first, which is hopefully you guys remember the critical value for a 95% Z, a 95% Z. I go a little bit out of order. Let's do the standard error first, and then I'll mention about a critical value Z. The standard error is just basically a square root of the p hat times 1 minus p hat divided by N, which is, again, we got p hat here, 1 minus p hat divided by N, which is, again, if you multiply them, divide by 517, square root of that will give me this item. So this is your standard error. To find the margin of error, we need to take the standard error, multiply to the Z critical value. And hopefully you guys remember that the Z critical value for a 95% by now. If not, you should be, is 1.96, right? Which is, again, this is the bottom of the table. The reason why I say you should, because as you will see, a lot of them ask you for 95%. That is like a common percentage they will ask you. They only need 95% of population. Remember, our cutoff for unusual is the 5%, which is, again, we basically say, if you are in the leftover 5%, we don't care about you. Not really, it's just common number is 95. As you will see, 1.96 is a Z. Again, we are dealing with the Z critical value, so we're not dealing with a T critical value. So this is what we have. So once we have this, which is I took 1.96 times the standard error to give me this number 0.03573759, which is, again, how do I find a critical value? I mean, not critical value, a confident interval, which is now to find a confident interval, I need to take the point estimator, subtract point estimate, subtract the margin of error, and point estimate plus the margin of error, which is, in this case, this is what I have, which is, again, I know you look at this thing and you say, oh, how many decimal do I want? Again, if you do this by hand, you want to keep as many decimal as you can. You only round up at the final answer, at the last portion, okay? And again, I looking at this thing here, you probably is confused with all the decimal. It's just, I just basically type whatever, how many decimal the calculator give me, I type it here, and that's what I have. And again, it's close enough. So looking at this thing here, first of all, question would how to find a point estimate for the proportion, how to find a standard error for the proportion, or how to find a margin of error for the proportion. Now, looking at this thing here, and like I mentioned to you guys, your best friend, your calculator can help you. And he or she, your calculator, can do wonder, right? But again, you have to know how to ask your calculator to compute your item for you. So looking at this thing here, your calculator do have a feature to find this confident interval for a proportion. And what is that feature? It's the same feature as before, which is you hit stat, you go over to test, and you go down to one prop Z interval. Everybody see option A here. If you keep on go down, they have one proportional Z interval, which is
not see your
We can't see the calculator.
Sorry. Again, if you go to your calculator like before, which is you hit stat and you go to test and you go down, keep on go down past the T, you have one proportional Z interval, which is option A. Again, we are using one prop. We are not using two. We only have one data. We don't have two. We only have one variable. We don't have two variable. And also make sure that it's a one proportional Z interval and not the one proportional Z test. Number 5, we would do that later. We not do it now. Again, we have to go all the way down to A. Everybody see option A. Option A, one proportional Z interval. If you click on that, now they ask you this question is, what is your X? Which is, everybody see your X is 403. That is my X. What is your N? Which is your N is 517. And what is your confident interval, which is in this case, my confident interval, they asked me for 95%. So everybody see that we need to adjust to 95, which is, this is what I have. And again, once you have this, which is again, all of this calculation, all of this square root, all of this item here, your calculator do it for you, which is looking at this thing here, we have 0.7437, which is, that's why I have 0.744. And again, 0.81523, which is 0.815. So again, and they have the p hat for you too, which is the p hat, 0.779497096. That is my p hat right here. So again, as you can see, like I mentioned, the only reason I show you not all this messy item is just because that if they ask you separately, if they ask you find the point estimator, you know how to find a point estimator. If they ask you find a margin of error, you can find a margin of error. Your calculator output doesn't give you any of those, right? So again, the output only give you the interval. So if they ask you for the interval, then you can do it. You can find the interval, right? You can use, again, everything is the same, right? You hit stat, you scroll down to test, and then you use the one pop Z interval, one proportional Z interval. And like I keep on mentioning to you guys, the hardest part of this class, right? The calculation, the calculator do the calculation for you. The hardest part is how to tell your calculator to do it, right? How to tell them, okay, you have to tell them, is it the Z interval? Is it the T interval? Or now the last one, is it the one prop Z interval? Okay, so everybody see how to use your calculator, how to tell your calculator to calculate this proportional for you. Question of how to use this proportional item. All right. Well, let's do this tomorrow. So if you don't have question, let's stop here for today. Like I said, we still have a small part of 7.3 to go over. So tomorrow we will finish 7.3 and we will do 7.4. But again, 7.4 is just basically review of chapter 7. So tomorrow we will do more problem. And if I throw a bunch of problem at you, can you decide which one to use? Because that is the main objective of chapter 7. Do you know when I'm using the one prop Z interval? When do I use the Z interval? And when do I use the T interval? Because the calculation is clearly, hopefully, easy. The hardest part is for you to decide, right? So tomorrow we will look in more detail of the problem, and hopefully tomorrow you can distinguish the difference between the 7.2 and 7.1. 7.2 and 7.1 probably is the hardest one to distinguish, because this thing here, if they say find a proportion, if you see the word proportion, you have to use one proportion Z interval, one prop Z, right? So again, first of all, question here. All right, ladies and gentlemen, if you don't have question, let's stop here for today. Be safe out there and have a good day. If you have question and you want to ask me, please stay back. I'll be here a few minutes. And if you don't, have a good day. I will see you all tomorrow, same time, same place. And again, if you haven't typed anything in the chat, please do so. And I will see you all